Today we will be covering 4 different methods of solving systems of equations: substitution and elimination, augmented matrix and row echelon form, Cramer's rule, and inverse matrices. First, let's look at a system of equations and solve it with substitution and elimination. Our example is 2x plus 5y equals negative 16 and 3x plus 4y equals negative 17. We will be using elimination first, as this example already has both x and y on one side of the two equations. Additionally, x and y are already vertically aligned. So first things first, we want to eliminate one of the variables. To do so, we need to find the least common multiple of the coefficients of a variable so we can subtract it to become 0. In this case, I'm choosing to find the least common multiple of the coefficient of x as it is smaller. The least common multiple of 2 and 3 is 6. So we multiply each equation so that it starts with 6x. Remember to still align the variables of the two equations. Then we subtract. 6x minus 6x equals 0, 15y minus 8y equals 7y, negative 48 minus negative 34 equals negative 14. Divide 7 on both sides and we get y equals negative 2. Now we substitute y equals negative 2 back to the first equation, 2x plus 5y equals negative 16. Simplify and then we will find that x equals negative 3. Our answer is x equals negative 3 and y equals negative 2. Next, let's look at an example of augmented matrix and row echelon form. The problem will be 60x plus 120y plus 60z equals 720, and 40x plus 90y plus 30z equals 490. Finally, 15x plus 10y plus 20z equals 130. The goal of this method is to rearrange the matrix so that it is in row echelon form as shown in the top right corner. The first thing would be to write the system of equations in augmented matrix form, which is basically the coefficients of the variables on one side of the matrix and the constants on the other side, separated by a dotted line. As mentioned earlier, the goal is row echelon form. To do this, we modify the matrix by multiplying constants to different rows and adding or subtracting one row from another. The first thing I did was multiply row 3 by 4 and subtract that by row 1. Notice how I make little notes of 4 times row 3 at the bottom of row 3 in the previous matrix so that I know what I'm doing and I don't make little mistakes. This eliminates 15 in row 3 and gives us the start of our row echelon form. Next, I multiplied row 1 by 1 over 60. Notice it's multiplied, not divide, because we can't divide in a matrix. The point of this is to change our first row so that it starts with 1, which is the requirement for row echelon form. Next, I did row 2 minus 40 times R1. This was so that row 2 also started with 0, just like row 3. By this point, I have the first column of my matrix in row echelon form. Then I did row 3 plus 8 times R2. This gave me the second 0 for row 3. At this point, we're almost done. You can sort of see row echelon form with the 3 zeros at the bottom left corner of the matrix. The next thing I did was multiply row 3 by negative 1 over 60. This would give me the 1 for row 3. Then I multiplied row 2 by 1/10, which gives me the 1 in row 2. Then we do a little bit math. Z equals 2 from our row echelon form matrix. Y minus 1z equals 1, which is equal to 3. X plus 2y plus 1z equals 12. Do the math and it's equal to 4. Summary: x equals 4, y equals 3, z equals 2. Our next example will be done with Cramer's rule. Our next problem will be x plus 2y equals 12 and 3y minus negative 4z equals 25. Finally, x plus 6y plus z equals 20. To solve this with Cramer's rule, we'll just be putting the system of equations into the formula as shown in the top left corner. However, before we apply the system of equations to Cramer's rule, I will rearrange the system of equations so that x, y, and z are vertically aligned. For variables that don't exist, I'll be adding them in with a 0 as a coefficient. This is just so that it is easier to write the matrices from Cramer's rule later on. Next, we write out what a from Cramer's rule equals and find its determinant. As to find the variables and their values, we will need the determinant of a. Quickly inputting it into the calculator, the determinant of a is 19. We find the value of x by using the formula and its corresponding values in the system of equations. With the help of a calculator, we will get 114 over 19, which is 6. The same process of using the formula according to the corresponding values of the system of equation will be used to find the value of y and z. Y equals 3 and z equals -4. As a summary, our answers are 6, 3, and -4. Finally, we will look at inverse matrices. The problem that we'll be solving is 5x minus 2y equals 11 and -4x plus 7y equals 2. The first step is to rewrite the system of equations to matrix form, which is ax equals b. Then we find the inverse of a. We can do this by putting in the calculator, or in this case, I did it by hand. Then we multiply A inverse to the matrix equation from step 1. This eliminates matrix A, giving us the direct value for x and y. This works because of the multiplication property of equality. Simplify and we will get the answer x equals 3, y equals 2. As a conclusion, please note that all of the methods work for all problems. For instance, the inverse problem we just had, we can also use substitution and elimination to solve it. I will not explain the substitution and elimination method again, but it is written on screen. Both methods will still generate the same answers. The point of having multiple methods is just to make problems easier to solve. For instance, when there's 3 variables, it's harder to do substitution and elimination.